Now, this is the next article, a stable multivibrator. In that article, we firstly explain the circuit diagram of a stable multivibrator and its working using IC555. And from the output of the stable multivibrator, we find the period, frequency, and the duty cycle. A stable multivibrator using IC555 is a simple oscillator circuit which generate a continuous square wave. A stable multivibrator has no any stable state, as well as it does not require any external trigger. Therefore, a stable multivibrator is also named as free running multivibrator. Now, what is its circuit diagram? That is shown here. Circuit diagram which we represent here, it shows IC555 whose all pin connections are given to the external components like RA, RB, capacitor, supply, and then we measure its output at the terminal 3. Now, what is actual working of IC555 that we discussed earlier? We again repeat in short how it works and what is the output of a stable multivibrator, how it becomes free running multivibrator, that we explaining here. The working of IC555, as we explained earlier, we know that in that case IC555 has two comparators. Lower comparator we call comparator second and upper comparator we call the comparator 1. How they are connected in IC555? The trigger terminal 2 is connected to the inverting terminal of the comparator second, which is the lower comparator, and it forms S as a input of the flip-flop. Similarly, the threshold terminal 6, which is connected to the non-inverting terminal of the comparator 1, and it forms R as a input of the flip-flop, that is shown here. Comparator second, it forms S as a input of the flip-flop. Comparator 1, it forms R as a input of the flip-flop. That the S and R may be low and high, it depends upon the actual voltage across the terminal 2 and 6, that we explaining here. We say that the actual working of a stable multivibrator, when supply is on, then what happen? The voltage across the pin 2, that is the trigger, its voltage is below 1/3 VCC. So that the lower comparator second, its output is high, that is S is 1. Automatically other comparator is 0 and the output of the flip-flop is low. If output of the flip-flop is low, that condition is flip-flop is in the set state. The low output gets inverted at the NOT gate and it becomes high. Therefore, output of the timer at pin 3 becomes high. Such a low output is given to discharge transistor. That transistor is turn off or we say cut off, and capacitor gets charging through the resistor RA and RB. How it's charged, that way also shown here. Initially we know that power is turned on, flip-flop is in the set state, output of the timer is high, that is shown here. In that condition, the capacitor start to charge. That charging of the capacitor increases exponentially. If the voltage across the capacitor is reached near about 2/3 VCC, then what happens? The comparator first, its output is high. Comparator first output is high, that is R is 1, S is 0, and output of the flip-flop is 1. Output of the flip-flop is also high. In that condition, the flip-flop is in the reset, and if it is in the reset, then output of the timer becomes low. That is shown here. When the output of the timer is low, then how the capacitor behaves in that region. If the voltage is just slightly increased above 2/3 VCC, the capacitor start to decrease if the flip-flop is in the reset state, and that discharging decreases exponentially up to the 1/3 VCC. If the voltage across capacitor is slightly below 1/3 VCC, then again the comparator second becomes high and flip-flop is in the set state. Output of the timer becomes high, that is in that region. Again the capacitor start to charge. Discharging increases exponentially. When it again reach up to the 2/3, that process is continued. The process of charging and discharging of the capacitor is continuously repeated so that the output of timer goes alternately high and low, and it generates a square wave. Such a result of the at the output, it shows a square wave, and corresponding charging and discharging is shown here. Now how to find the period and frequency as well as the duty cycle from the output of the stable multivibrator, that we are also discussing here. Here it shows the time t is the sum of t on. When we get the t on, high if the output of the timer is high. T off, we say that the output of the timer is low. And when output of the timer is low and high, that you know, when capacitor is getting charging, the output of IC555 becomes high. When capacitor is discharging, the output will be low. And so that no any state is stable. Therefore, it is a astable mode. Astable mode, and in that astable mode, it is also goes alternately. Automatically, it interchanges state from high to low, again low to high, high to low, alternately, and therefore it is also called as free running multivibrator. Hence, a stable multivibrator is a free running multivibrator, that is shown here. Now that is the time period t. When t is on, now what is the discharging time constant when output of the timer is high? When it is in the set condition, capacitor gets charging, that the charging time constant is Ra plus Rv multiplied by C. When capacitor gets discharging, then what is charging time constant? It gets discharges through Rb only, and therefore we say that the discharging time constant is Rb multiplied by C. Using these two terms, we find what is total time period and what is its frequency and what is the duty cycle. Duty cycle is the ratio of t on by total time t. That two terms we calculate here. Now how to find period, frequency and the duty cycle? As per earlier discussion, we firstly note what is the charging time constant? That charging time constant we define by T on. It is equal to 0.693 multiplied by RA plus RB C. And what is discharging time constant? T off is equal to 0.693 multiplied by RBC. Since RA plus RBC is the charging time constant and discharging time constant is RBC, and therefore we calculate T on and T off. Therefore total time T is equal to T on plus T off. We substitute these two terms in that equation, take 0.693 common, and bracketed term we simplify, RA plus RBC plus RBC. Therefore we get RA plus twice RBC. As we know the total time, then we easily find the frequency. Frequency relation, you know, it is the reciprocal of total time. Hence F is equal to 1 by T. Put the value of T. Equation becomes F is equal to 1 divided by 0.693 times RA plus RB multiplied by C. Or if we simplify 1 divided by 0.693, the ratio is 1.44. Therefore, the equation we also write in terms of 1.44 divided by RA plus twice RB bracketed term multiplied by C. Then we find what is the duty cycle. Duty cycle we defined earlier. It is the ratio of T on by total time. We put same relations here to the numerator denominator term and simplify. T on 0.693 multiplied by RA plus RB multiplied by C, that is take numerator. Denominator total time T is equal to 0.693 into bracketed term RA plus twice RB multiplied by C. Now here 0.693 is common to the numerator denominator. It get cancelled and we simplify the term. RA plus RB C is also common term. Numerator denominator it get cancelled and only remaining term is RA plus RB divided by RA plus twice RB. In terms of percentage, now what is the duty cycle? We have to multiply it by 100. In percentage, we also find duty cycle. Here we say that if RB, that resistor which is connected in between RA and capacitor, when what is the effect of the resistor RB and R1? Now we say that if RB tends towards 0, then what happens? RB tends towards 0. Numerator term becomes RA, denominator is RB. RA did get cancelled and we get 100% duty cycle. But as RA tends towards 0, then what happens? That RA is 0 tends towards 0. We cannot say that equal to 0. It is tends towards 0. RA tends towards 0, then remaining term is RB divided by twice RB. Therefore, RB cancel, we get duty cycle becomes half. Hence, remember, as RA tends towards 0, the duty cycle decreases to 50%. And if RB tends towards 0, duty cycle is 100%. Hence, the duty cycle may vary in between 0.5 to 1, it depending upon the two resistor values, RA and RB. And that is the complete term which come under a stable multivibrator, its actual working and how to find period, frequency and duty cycle. All the terms we discussed here. Thank you.